will be our DGM sir, and it is a keynote lecture on multi-hazard early warning system interoperability with example of heavy rainfall monitoring and forecasting, standard operating procedure. So now I will request our DGM sir to kindly start the talk.
Thank you, Dr. Patnaik. So good morning to all of you again. I extend a warm welcome to all of you for this 5-day regional training workshop on multi-hazard early warning system interoperability implementation. In today's presentation, I'll just give an overview of the objective and how it can be done. That I will demonstrate you with one example. So all of us are the forecasters. We work in different capacity in our country to provide the forecast to various users. Sometimes you will find that you have given a good forecast, but response is not good. People cannot take actions, or forecast cannot trigger actions. Okay. But I want to say that even if you have given a very good quality, timely with the forecast and warning, that may not guarantee the safety of life or prevent major economic disruption. The reason for that could be many. For example, you have got the weather models, and there may not be the hazard models. For example, we have a very good forecast for heavy rainfall over Kerala during this monsoon, but we do not have the adequate landslide modeling system. Similar is the case when it rains heavily in Himachal Pradesh, Uttarakhand, or Nepal, or Bhutan. We have a good forecast on heavy rainfall, but we do not have the landslide forecast. So qualitatively, we issue the landslide forecast, but we could not provide the way in which we provide the heavy rainfall warning. The landslide warning is not provided. Similarly, there could be the storm surge. The storm surge modeling depends upon the various parameters: meteorological parameters, geophysical parameters, socioeconomic conditions, and also the local topography, bathymetry, etc. If you do not have high resolution bathymetry, you cannot have the coastal inundation realistic. Even if you have predicted good weather model, you have given very good track forecast, intensity forecast, but if your coastal inundation model is not taking into consideration the rainfall, not taking into consideration the river runoff, not taking into consideration the dynamic changes in the track intensity structure of the cyclones, then your storm surge forecast may not be realistic. Say, for example, now we have got the coastal inundation modeling that is specific to India. We provide the coastal inundation model guidance for other countries based on the USGS data. We do not have our own digital elevation model data from other countries, so that it becomes a rough estimate, not so much highly accurate estimate of storm surge for other countries. There could be the scientific and technological capacity to translate hazard and information into impact. Recently, we have started in all countries providing the impact-based forecast. But if you do not have the models to define the hazards, you do not have the models to have the realistic assessment of the impact, then your impact-based forecast may not be so correct. Many countries, they provide impact-based forecast based on the historical facts. They are not able to take into consideration the dynamic behavior of the, say, population density, type of houses, rivers, bridges, culverts, railway lines, national highways, international airports and national airports, so many utility centers like hospitals, schools, colleges, shelters. So if these data are not digitized and not available in your decision support system, you cannot provide a dynamic impact-based forecast, even if you have got a good weather forecast. Now next comes the inadequate communication channels. You may have the communication channels for exchange of data through GTS, or now it is WIS. But you may not have the sufficient information channels to provide the data or information to the last mile. A person who is staying in hilly areas in Nepal or Bhutan or Himachal Pradesh, Uttarakhand or Jammu and Kashmir, there may or may not be the telephone lines. There may not be the towers, even northern parts of Pakistan. So how to reach there? So therefore, the inadequate communication channel sometimes will fail you. Even if you have given the forecast, it is not reaching the people. Okay, I'll give a good example. It is not simply the telecommunication channels, but also it is the language. Say, for example, you issued in certain language, but the local people do not understand that language. It so happens, sometimes I will tell you, in 2018, there was a cyclone which hit Andhra Pradesh and Odisha coast, and we gave warning. People are saved from the sea, no fishermen died, but 18 tribal people, they took shelter in a cave, and that cave collapsed. They could not get the informations. So, because the information is not provided in the tribal language, it is in English, Hindi, or local language, but it is not addressing to the dialects of the people. So people don't understand. Similarly, there could be lack of appreciation and utilization of available vulnerability informations. Local maps. You may not have the local maps. You are just looking at, say, all India, or looking at Nepal or Bangladesh or Sri Lanka, but you are not looking at so specifically zoomed maps. That facility should be there. You should have that type of data and maps so that you can superimpose those maps with your forecast, and you can find out locally, location specific impact and the forecast. And therefore also forecast is generated at that local level. So we have come up in a recent time that Mosamgram, that is wherever you click, you will get a forecast. So all these things therefore matters a lot when you issue the good forecast and expect there should be a good response. And no effective decision support system. We do not have decision support system for each and every severe weather. We do not have decision support system for the general public. We have decision support system. So recently we have come up with our indigenous developed decision support system that we will show you during the training program. So this is also an issue. If you do not have decision support system, you cannot deal with such a data. It is a big data nowadays. Whether concept for AML is there or not, different issue, but it is a big data concept because you are looking at so much of data at a time. So you should have a support system, computerized support system, that is a computing platform where you can compare, comprehend, analyze the different types of informations. Now, so with all these issues what I discussed, now next question comes, how can science deliver this one so that you can save the people at last mile? You can reach out to the last mile. The first and foremost thing is the institutional strengthening. We have to strengthen our institutions. It means whatever forecasting institution we have got, observation institution we have got, modeling institution we have to work together. Then we have to improve our observing and forecasting systems. Certainly, the remote area, we have to improve our observations, forecast system. But I will tell you as a forecaster, I will not wait till the observation system improves. Whatever observation system is there, direct and remote sense observations, that will utilize, okay, to provide the best forecast. So we have to need to understand why people do not move to safety when a warning is issued. Maybe there is a lack of consistency. You have issued one forecast in the morning, in the afternoon you change the forecast. Again in the night you change the forecast. Next day morning again you come to the original forecast what you issued today. So this type of consistency lack of consistency will not give confidence to the people to follow your warning. So as a forecaster, you should be consistent. You should not check. While you take a decision, take a judicious decision. Do not change the forecast very frequently. And when you change the forecast, please explain. For this reason, we are changing the forecast. Otherwise, people will not believe. Then accuracy of forecast, of course. Forecast cannot be 100% correct. But you have to verify the forecast. Each and every forecast should be verified. And you should tell your users, disaster managers, stakeholders, public, see, this is my forecast accuracy. For example, we verify all our forecast here. Say my heavy rainfall forecast accuracy is 80% correct, 24 hours ahead. So then disaster managers will come to know by whatever forecast they are issuing, there could be 20% error, 20% missing. there could be 30% false alarm. So that they will take care. They are also very intelligent people. They will utilize, but you have to tell them. If you do not tell, if you hide what is your forecast accuracy, it will not help. So by improving your forecast verification, by telling the people about the forecast accuracy, you are also strengthening them to take a decision. Your uncertainty is communicated by telling your forecast accuracy. Then there could be, they do not know the dangers, their lack of awareness. You have to go for increasing the awareness of your stakeholders. So therefore, there should be training continuously to improve the awareness of stakeholders. You cannot improve the awareness of the public by training. You cannot go for public training. What can you do? You have to prepare the materials like frequently asked questions, the terms and terminology, do's and don'ts, real-time platforms. Sometimes, for example, you can go for Facebook Live, or you can do Google, or you can go to YouTube Live, and you can interact with the people, take their, you can have a feedback form in your website. So by that way, you can increase the awareness of the public. And awareness of the stakeholder can be increased by going for the systematic training procedure. Every year, for every type of severe weather, there should be training. So they know it, but choose to ignore it. Say, for example, pressing need. For example, I will tell you, people go to Chardham, where you have got some religious places. There will be some areas, or you go to Ajmer, or you go to, for example, the places in Uttarakhand we have got. Then Kailash Manasarovar in China. So people go there in large number, and there is a fixed period. In that period, if they miss, they cannot have the darshan, they cannot visit. So therefore, there is a pressing need. They don't want to ignore, and they want to take the risk. Even if you are told that there will be heavy rainfall, there will be landslides, they used to go. So there, what you have to tell, what you have to do actually, you have to show the examples. You see, if you go, this is the risk. So therefore, they know but ignore it, but press need or objective. So we have to take care of that to convince the people, convince the disaster managers that people should not be allowed. Okay, action is on their part, but early warning should be convinced to the people so that they can take actions. Then scientific language. Sometimes we feel that whatever we are writing, that is correct. No, you are writing based on your knowledge. So about the content of the bulletin, about the language of the bulletin, we should also discuss with the stakeholders. We should take their input. And as a layman, when you are writing as a forecaster, you should also treat yourself as a layman. First, yourself you see whether you are able to understand. If you are a farmer, if you are a fisherman, or if you are a tribal person, or if you are a businessman, or if you are a vendor, street vendor, whether you are able to understand that bulletin. Sometimes we write, I have changed many times when our forecasters come to us. Every day we discuss the cyclonic circulation extends up to middle tropospheric level. A common man, how will you understand what is middle troposphere? Then like above means sea level. So these are the terms people do not understand. And sometimes we will write like this, it is tilting southwestward height, and it is up to 3.1 kilometer above mean sea level. General people will think that, how accurate is this? You see, circulation is extending up to 3.1. They don't understand that, no, this is the standard isobaric level of 700 HPA, therefore we are writing 3.1. So this is not required actually. When you are communicating to the public through press message, these are not necessary. Simply cyclonic circulation is sufficient. So these are the things, sometimes our language becomes so much complicated for the common man. You write all these things for your inference, you write all these things for your technical consumption, but for general public, the language should be very simple, easy to understand, easy to trigger actions. So these are some of the things I just wanted to tell you. Now, what is happening actually? Just like Secretary was telling, we are going for a paradigm shift. Earlier, we were telling that we want to give you the forecast, whether there will be rain tomorrow or not, whether there will be heavy rain tomorrow or not. But over the period of time, what we have done, especially in last 5-6 years in every country almost, if someone is not doing it, should be done. We are providing impactless forecast. That is, we are telling what the weather will do tomorrow instead of what the weather will be tomorrow. That means we are moving from information-based forecast to impact-based forecast and risk-based warning. Okay, so we are telling now, not only there will be 12 centimeter rain or 30 centimeter rain over say Lahore or over say Delhi or in Dhaka next 24 hours, but we are telling whether that rain will lead to inundation in the city, then if inundation is there, which part of the city will be inundated, whether slum has to be evacuated, whether transport has to be regulated, whether the airport should be closed, whether trains should be regulated. There are so many things. So the school should be closed. So all social activity depends upon you. You are now in such a position, I'll tell you. You can decide the fate of the people. So therefore, we have to, when there is such a responsibility, the forecaster should be very judicious. And the forecasters should work in collaboration with everyone. If you collaborate with all these people those I named, then you will not commit mistake. Your forecast will be all right. Even if forecast is wrong also, they will take care. But if you do not consider them on your own, you are issuing the impact-based forecast, then it will be very risky. Okay, so the way moved like this, the left-hand side just observations and forecast, right-hand side is the impact. Now, so what are you doing then? I was telling you there are a lot of data. We have got the observational data now. Over the years, observational network has increased. We have got the surface gas, we have got the upper air informations, then we have got the satellites, we have got the radar, and there are many information like lightning, etc. So all this data has to be utilized. So there are 4 stages actually. First is the data, that is signals or no nothing actually. You got lot of data, you don't know anything. Unless otherwise you create some information useful. That we do by analyzing the charts, analyzing the informations, and to do that you need knowledge. So data is first converted into information, then comes the knowledge, the contextual synthesized learning. When I say knowledge, so for example, I am a forecaster, I am a synoptician, I am analyzing the chart. There is a satellite meteorologist, he is analyzing, Satya is here, he is analyzing the satellite information, he is issuing the forecast, he doesn't know anything about the synoptic, and synoptic person doesn't know anything about the satellite convection. He is just preparing one bulletin, he is sending, and synoptician is preparing the bulletin based on the synoptic analysis and sending the informations. Both are not in agreement with each other. So there should be synthesis. Similarly, on the other hand, there is a radar meteorologist sitting somewhere, and he is issuing radar informations. He is not talking to satellite, satellite is not talking to radar, and he is not talking to synoptic. All 3 are independent. Similarly, there is another group, lightning. There is satellite-based lightning, there is observation, ground truth lightning. They are also not communicating. There is upper air observations. So what I want to say that the knowledge can be generated if there is a synthesis, if there is a learning from each other, if all of you are working with each other with a context. Context is severe weather. Okay. The next is this knowledge has to be converted into wisdom. Once you got knowledge, it has to become wisdom. That means understanding. You should now understand the entire process, an integrated process. You are now understanding only satellite. Now you are understanding entire process with respect to the cyclone, with respect to the thunderstorm, with respect to heavy rainfall, etc. Entire understanding. And that understanding is integrated one. Now that understanding will be actionable. You have to convert this into a certain format, graphics, which is now actionable. So therefore, simple data is not useful. So we have got a big data concept now. All of data, any country you see, a lot of data are there. So this will enable you to provide the impact-based forecast and risk-based warning. Now let us see what happens actually while doing so. When you do this exercise, as I explained a little earlier, what are you doing actually? Now there is a challenge. You will say, how can I interact with the satellite person? How can I interact with the other person? How can I get data in one platform? I do not have computer. I do not have manpower. So all these issues are there, challenges are there, but objective is very clear. You have to work together. You have to exchange. You have to assimilate all information in one platform. So this challenge can be met with the methodology. Methodology, what I explained earlier. Then you will get a solution. Once you get a solution, you practice it. Make it a standard one. And every day you should do that. So for this purpose, the first is that user-first design concept. Your bulletin, I was telling you earlier, your bulletin or information should be designed in such a way that it keeps user at the front. Don't develop any bulletin or product based on your requirement or based on your ability. Always you should, if you are preparing a bulletin for farmer, you should watch a farmer in front. What is his or her requirement? How can he get the information? How can he or she interpret the information what you are preparing? How can he or she take a decision? If you think like that, then certainly you can prepare a better information for severe weather. So therefore, first one is A, that is user first design concept. All your products should be designed, all your bulletins should be designed taking user as the first. Then what do you do? Then you have to converting weather forecast to impact forecast. When you go for converting weather forecast to impact forecast, you need a digital grid, certainly. Digital grid, that is geospatial grid. And that we have, many countries might have, we do not have, then we can work together to develop that. We are willing to work towards that. Then surface data, then core algorithm. You got data, all this data, core algorithm. There is certain algorithm developed in the GIS system, web GIS system, then impacted forecast or warning can be generated. That we have done, that will be demonstrated during the training program. Then hasty decision to well prepared plan. Don't do like this. Market, we are moving around the market and came, duty starts now. Okay, let us go to office. And time, now it is time over, issue the bulletin. No, it is not like that. A forecaster should be in continuous monitoring process. Maybe you are following morning, evening, night duty roster, but you are not off today, but you should be refreshed. You should be refreshed in your mind what is going on. When you come to the duty, you remember it is going on and you go through all the informations and take a decision in collaboration with each other. Don't take a hasty decision. This hasty decision will lead to sometimes the mistake in your forecast, and it may lead to the wrong decision by the disaster managers. Then you have to go for broadcasting to interaction. That's what I'm telling you. What do we do actually? Now we have to issue a forecast based on, for example, 3 UTC by 12 o'clock or 1 o'clock in midday. We issued the forecast. Okay, there will be severe weather over eastern Nepal. Then we forget. Okay, this is not a fire and forget. If somebody has gone for shooting in the forest, he fired and forgot what happened. It is not like that. Here, you have to consider after firing what happened. You have given sea weather forecast today. What happened? Whether sea weather is going to occur. So every 3 hours or every hour you are watching, you have to watch and find out whether heavy rainfall is occurring or not. If heavy rainfall is not occurring, you have to update. You have to provide the informations. You have to interact with your local offices. You have to interact with the disaster managers. Tell that, okay, we gave heavy rainfall warning, but now we are withdrawing, or now we are downgrading, or now we are upgrading. Anything can happen. So that type of interaction has to be done, and that interaction is not with the disaster managers, that interaction with your people, and that interaction with the system, the decision support system. So this is required if you really want to be a broadcaster being converted into an interactor. That means in small way I will tell you, you have to be a smart meteorologist instead of a conventional meteorologist, what we did earlier. Now you cannot rest after issuing the bulletin. You have to be, what is the amount of rainfall is occurring? That information is to be given to the public. If you given severe weather information, then accordingly, I used to give an example to our people that is, say, a cricket match is going on. For example, Sachin Tendulkar, the great cricketer, he is batting, or Imran Khan is batting. Okay, now he is reaching 90. Here the commentator, Ravi Shastri or Sunil Gavaskar is telling, okay, Imran Khan or Sachin Tendulkar has reached 90 now. He needs 10 more runs to complete his 100. This will be his 50th 100. And before that, XYZ have done 50th 100. This will be 51st person or second person, third person in the world who will have this 100, etc. If this 100 happens, what will be like that? So this is a running commentary. But that running commentary is not coming out of his mouth. There is a dashboard. There is a decision support system who is helping the commentator to give your running commentary, and you are all enjoying. So like that, when say city of Karachi or city of Dhaka or city of Mumbai is getting, say now, we predicted today morning, there will be very heavy rainfall. And now at present morning we have issued at 3 UTC or 6 UTC, rainfall is 5 centimeter. 5 centimeter rainfall is sufficient to cause flooding in city areas. Now what shall I do? I cannot continue my forecast. I have to tell that 5 centimeter rainfall is there, rainfall is continuing. The latest convention indicates that rainfall rate will increase. We can expect 5 centimeter rainfall more in next 3 hours. Total rainfall may be exceeding up to 15 centimeter. We will be updating you next hour or next 3 hours. This is called as interaction. Just like running commentary provided by a person in cricket match, you have to provide the running commentary to the people, to the disaster managers, to the media. So there should be a system where we can do that. Yes, there are systems, there are WhatsApp groups, there are many media persons, there are the dashboards where it can be done. It is done, it can be done, I'm telling you. So this is what you need actually. Therefore, you need weather and climate extremes. You have got geophysical hazards. You need exposure. You need vulnerability. Then socioeconomic parameters, and all these things you have to quantify in a digital platform. Then you can provide the risk and assess the risk. Okay. So this is what you are doing. You are converting the weather information. You are translating it into impact estimation, and it is going to the disaster managers, general public for response. So response will depend upon the weather information, the way in which you are analyzing the weather, you are forecasting and generating the forecast data. Then you have to extract the relevant information from that forecast. Say every day you have given the forecast. For example, I have given forecast of heavy rainfall. I have given forecast heavy rainfall in Cherrapunji. For example, Mausinram, that is the wettest place of the world, 9 centimeter or 7 centimeter you have predicted. What I have predicted, for example, Ajmer or Jaipur, 7 centimeter rainfall. So what will be the impact? Impact is completely different. Cherrapunji, nothing will happen 7 centimeter rainfall. It is a day-to-day affair in monsoon. But there is a heavy rainfall of 7 centimeter in city of Jaipur or city of Ajmer. It will cause havoc. So therefore, the extraction of relevant information. So what will happen if there is 7 centimeter rainfall? So that extraction who will do? The forecaster has to do based on all the data available. So socioeconomic data you have got, geospatial data you have got, and you have got data on other parameters. Then the impact estimation you will do, vulnerability will analyze, and then you will provide a message, you will go for response, mitigation strategies. So finally, what you do is weather information was quite huge. You are thinking about that, but there are other information which has to be utilized for that. And these two different wedges you find, green wedge and orange wedge, when they will meet each other, your impact forecast will be really correct. If you are not meeting, then you cannot provide a realistic impact forecast. So what is done then? How can you meet these two wedges to make a rectangle? You have to interact, you have to collaborate with various agencies. There will be space agencies, there will be agencies in the state, there will be agencies in the local urban bodies to take the information, digital data, census data, for example. All these information has to be taken into consideration, and these two edges has to meet collaboration. Man-to-man collaboration has to be done. Machine-to-machine collaboration has to be done. Data flow should be free and continuous. Then it will be successful. Okay. So by this way, what we are doing at present, actually, we are assessing the impact forecast in color codes, and accordingly, we are giving the green, yellow, orange, red, etc. information provided. All of you know this. This color code was introduced in 2013 by the WMO, and all of us are utilizing it. And we provide the risk matrix. Low means it is very minor, medium means it is significant orange color, and high means it is severe. Or otherwise, we say low means we say just updated, medium means you say that be prepared to take actions, and high means say we take actions. Okay, and finally we will take actions to whom you are providing. You are providing the common people, and you are providing the okay. You are providing the information to common people. You are providing information to different communities. You are providing information to various stakeholders. So entire process we have seen there. So how is it occurring? So from large scale weather patterns, now we have come up to a forecast for a particular city or particular town or a particular people. Okay, so all these things, all of you know that. So objective is the severe weather forecast program. What we are doing, this is to be best like this. Okay, and let us look at the impact forecast what we issued actually. Many countries manage the capability, but I will tell you any country can do impact forecast. There are various stages of impact forecast for the severe weather. The first stage is the threshold method. You define threshold, but that threshold cannot be same for different cities and towns and different states. So what happened actually in India, for example, we took 7 centimeters heavy rainfall, 12 centimeters as very heavy rainfall, 21 centimeters as extreme heavy rainfall. It is all India applicable. But we found that by applying this all India, it is not helping. So you have to consider the local conditions. Accordingly, you have to go for. Now we have changed a little with respect to heavy, very heavy, and extreme heavy for hilly areas, for plain areas, for cities and towns. So however, based on this threshold, you can give the different color codes. For example, we give heavy means yellow, very means orange, extremely heavy means red. This is very simple. You produce the threshold and give the one. It's very simple. The simplest method of impact risk forecasting you can go. Then comes the qualitative combination method. So here what happens actually, historical data, historical assessment. The synoptician knows what happens. So for example, Mr. Radheswamy is here. We have given heavy rainfall warning for Jaipur. He knows what happens if there is 7 cm rainfall in Jaipur. So that information can be utilized. You can combine with the threshold. That is called a qualitative combination. This is qualitative, not quantitative combination. This is qualitative combination of the impact with the threshold. Then becomes little better. This method is little better. Accordingly, you can see this is an example I've just put up here. What we mentioned in the earlier example, there was nothing information about what is the impact. Only the color code was there. And this information you can find out. There is some information about what will happen. It is being given qualitatively based on the historical information, what you've seen in the past, that is being utilized to develop this one. Now, third one is the impact modeling. The impact modeling. The impact model means what? For example, I have got the data for last 50 years, for example. I can develop an impact matrix. I can find out in a particular district or in a particular city, in the past, there will be 100 cases when there has been heavy rainfall, and what has happened actually. If there is heavy rainfall, what is the type of damage? That is recorded, and based on that, a matrix can be generated for given district, what is the impact expected. So this is called impact modeling. And finally, what happens actually, we can go for climate sensitivity method. The climate sensitive method means it is the final method, dynamic method. So here what are you doing actually? You are going for real impact modeling. For example, if you have got predicted hazard of rainfall, heavy rainfall, based on that heavy rainfall, where is the area which will be inundated? We have to go for digital elevation modeling. We have to go for drainage system of the city. We have to go for population density. All things in one platform, it will be kept there. It will be analyzed, compared, and finally you will identify with a polygon. Now, you know, Commonwealth protocol, all of you are doing. We have to draw a polygon of the area where you are expecting red color, or expecting orange color, etc. And once you select the polygon, within the polygon, whatever damage you are expected, that will be postulated, that will be digitized, that will be shown. So this is the case of final one, the fourth stage, and it will help you. This is an example of climate sensitive method. This is the case for a tropical cyclone which crossed Andhra Pradesh, Golaf, on 24-28 September 2021. You can see satellite picture in the middle, radar picture on the right hand side, and the left hand side top is the track of the cyclone. So what we do actually, the system has been developed, dynamic impact-based forecast system has been developed for tropical cyclones in the country, where you can have all these, what I told you. You can have the threshold, you can have the historical data, you can have the impact modeling of the heavy rainfall, then you can do landslide, and you have the information about the flooding, you have the information about the coastal flooding, and damage expected in terms of agriculture, building, essential facilities, transportations, other facilities, etc. All these are quantified. And you can see on the bottom, you can find out what is the loss by category of the various exposure elements in different zones of the coastal areas. So these are all again converted into rupees. You can find out what is the amount of loss in terms of rupees, Indian rupees. So this is the advance. This is the fourth stage I showed you. The fourth stage example is this one, where you can have an end-to-end impact-based forecast of the severe weather at a granular level. Now, this is again another example, methodology of climate sensitive method. So here, whatever you told and earlier one, that Gulaf, what happened actually, the heavy rainfall occurred. This is the satellite MORS data set on the left hand side top diagram. It shows how much rainfall has occurred with the tropical cyclone, and the middle one on the right hand side is the point-wise rainfall activity, what happened in North Andhra Pradesh, for example. As a result, what happened, heavy rainfall and flooding, etc. occurred. So your forecast is now verified. What forecast you get for impact information. So what I am to say that this is the last mile where we have to reach for each and every severe weather, so that we can have all observations, models, forecast, and then impact forecast based on hazard analysis, then risk assessment, and communication, dissemination, then verification. Now, so while you go for these operational shifts, now we are in a transition stage. We are moving from single hazard forecast to multi-hazard forecast. Because nowadays, when you say any hazard, it is multi-hazard in nature. It is not single hazard. Single hazard forecast to multi-hazard forecast. You cannot tell that I am giving the forecast for heavy rainfall. I am least bothered about landslide. No, you have to take into consideration landslide. You are giving heavy rainfall warning. You will say that urban flooding, I am not bothered. No, you have to take into consideration. You are giving heavy rainfall warning. You cannot say that river and flooding. No, I will not look at river and flooding. No, you have to look at river and flooding. So therefore, you have to go for a single hazard concept to the multi-hazard concept. Second one is the phenomenon-based forecast to impact-based forecast. You cannot say that only I will predict rainfall, I will not predict the impact. No, you have to predict the impact. Then product-based services to decision support services. Now you cannot say that, okay, my work is done. I have prepared the product. Okay. No, you have to finally go decision support service. So for example, Dr. Pusher is delivering our multimodal and sample products generation. He prepared the multimodal and sample products, then told, sir, my work is over. I have prepared multimodal and sample products. No, work is over only when that multi product is converted into decision support system products. Like we generated for South Asia, every grid wise, what will be the impact of this heavy rainfall? Then we put up the green, yellow, orange, red color. That is also again not the end. There again we have to add socioeconomic parameters, the landslide parameters, other secondary hazard parameters. So work is going on. So we are moving towards the direction so that we can convert the product-based services to decision support services. So that looking at your product, a decision maker can take a decision. That is the objective. Madam, so if there is a forecast for Colombo, then it has taken into consideration that not simply the heavy rainfall forecast for Colombo, but it is end-to-end forecast that how much impact will have in the city of Colombo if we have got forecast for Colombo. Then meteorological threshold-based warning to impact-based threshold-based warning. Now at present we are seeing the warning based on the meteorological. Sometimes it may so happen, I'll tell you, now the winter. Yesterday you might have got to the rain in Delhi because of the western disturbance. Western disturbance hardly will give you heavy rainfall in northwest India. It will give many times the plains northwest India 3 centimeter, 4 centimeter rainfall. But do you know what is the impact in Pakistan and etc.? The mustard, the wheat. So many things are there. Even if it is not satisfying the heavy rainfall criteria, it has got a high impact. But you are not issuing warning. You are telling that no, it has not crossed my threshold. I will not issue warning. But there is an impact. So we have to move now from the threshold-based warning to the impact-based warning. Sometimes it may so happen that it is the mustard, it is in flowering stage, and there is strong winds at 10 to 20 km/h, and there is heavy rain. Not heavy rain, 3 to 4 centimeter rainfall. It will have large scale damage. Or sometimes in the sowing stage, there is a rain of 3 to 4 centimeter. It may help certain crops. It may also mar or destroy certain crops. So that you have to take into consideration. How will you do that? You will say that I am a synoptician, I am a issuing forecaster. How can I know about the agriculture? Now, this is the interoperability. You have to talk to your agrometeorologist. Agrometeorologist also should work with you in the same platform. And you have to work together and give the impact for agriculture. Similar impact on other industries, aviation, marine, etc. So many things. It has to work together. Then it is the standalone operational environment to interoperable environment. So therefore, finally, what we are discussing, you need an interoperable environment instead of the standalone environment working in different rooms. This is for flood forecasting. This is for flash flood guidance. This is for, it will not work. You have to work together in a common hall, or there should be interaction in virtually so that all can work together. There could be virtual interaction also. Yeah. So by the way, another thing is that while doing all these things, you cannot give the deterministic forecast. You have to go for probabilistic forecast. You have to indicate the uncertainty range in your forecast. Of course, we have adapted probabilistic forecast. We cannot go for that. Okay. So finally, I'm talking about the smart meteorologist. Okay. Now, a meteorologist has to be smart one. A meteorologist should have the capability. A meteorologist should have the capacity. A meteorologist should have the credibility. Okay. These are the three important components of a meteorologist. The integrated authoritative voice. A meteorologist is an integrated authoritative voice. He cannot speak only about the synoptic feature. He have to speak everything taken together. So he has to take into consideration the partnership. He has to develop partnership. Now he's a big one now. He should be humble. He should be submissive. He should have the characteristic to work with all other fellow meteorologists in the country. He should have that type of courtesy to talk to seniors and juniors, to carry along each other. He should have courtesy to talk to foreign countries because RSMC. So like that in the country or outside. So that type of quality has to develop for the forecaster. Apart from the meteorological knowledge, some human quality is also required for a forecaster. Customer service. You are dealing with a customer now, be it aviation, be it marine, or be it industry or somewhere. So you should have that type of aptitude to talk to customers, to take their inputs, suggestions, and utilize in your day-to-day life. Production. You should have such a production like industry. You cannot prepare so many informations manually. Automatic production you have to go. And there should be good quality control, etc. Innovation applications, you should be innovative, creative from time to time. You cannot continue as the standard method. You have to go for various applications, innovation should be there, and that can come if you work with each other. Okay. So forecasters have to work in multi-hazard early warning system, interoperable environment to improve accuracy and efficiency of IVF and RBW services. Unless you work in interoperable environment, I am giving you guarantee you cannot improve your forecast and you cannot improve the services. So all of you have to work in an interoperable environment. All of you have to utilize all resources. All of you have to talk to each other, work as a team. So that is the message what I want to say for a meteorologist. Now this is the interoperable environment that is circulated to all of you. That sharing of good practices, improvement regional collaborations, maximization of the available resources, including computing, infrastructure, and manpower, development of the synergized standard operation procedures, and strengthening of national and international coordination and arrangements, sharing of data and products, integration of various services, minimization of numbers. So I will not repeat because all of you know that, but I'll just highlight certain points. The sharing of good practices. There are SOPs developed by different countries for different purposes. Please share with each other. And let us assess, let us know which country may have. For example, some country may have better SOP for a given particular events, events. If we know each other, then we can have our standard practice better. Then there could be thumb rules. For example, for thunderstorms or heavy rainfall, there could be thumb rules and which does not share. If we share it, then we can improve our forecasting accuracy. Sharing of success stories and failure stories also can help to lessons learning. Now, you can also have improvement regional collaborations. Say, for example, there are many organizations in this area. We have got ICMOD, we have got RSMC Tropical Cyclone, RSMC Weather Forecast Program, RSMC Southeast Asia Plus Guidance. We have got, by mistake, RBS written, SASCO, Southeast Asia Climate Outlook Forum. We have got RIMES. So many people are playing here and not talking to each other, not working in a tandem, and not providing common information. So that is the need of the hour. There is no free flow of data from one RSMC to other RSMC. All work as standalone systems and centers. Though the target user is same in the country in the same place, for example, and you will find that the guidance products are many. They are going from different sources. A particular forecaster who is sitting in, for example, in Nepal or Bhutan, he is getting information about the flash flood, he is getting information about the Southeast Severe Weather Forecast Program. There's so many things, and which one he will utilize. How will he utilize? So maintenance of duty rosters are separate for different sources of information and products requiring more manpower. Data originated by different regional centers may or may not be compatible among themselves and with the member countries. Data are not compatible. So therefore, you cannot put up in GIS, you cannot put up in common platforms. So these are the issues why I'm highlighting here. The MIE, that is multi-hazard early warning system, interoperable environment, can help in streamlining the guidance product, data flow to minimize the exposure, minimize the expenditure, human resources, and focus it for end users and improve efficiency and accuracy. Now let us look at the improvement regional collaborations a little further. So there are many WMO recognized centers, as you told you, the training is not focused. Only training, if you look at training for cyclone forecasters, is a standard one. Every year is conducted for this region. Otherwise, other trainings like severe weather forecast program, we do not have regular training. Flash flood guidance, we do not have regular training. Because of what? Because of the shortage of funds. And what we do actually, people are now asking the tropical cyclone forecasting to mix everyone to put in tropical cyclone forecasting. But that can be done again within 2 weeks. So we have to think about that. How can we improve the training programs? Same model is being utilized for all these forecasts. So we have to plan in such a way that training is available for each and every work, and more people are trained instead of going in a haphazard way. So, but training will improve the capacity building, data flow, disseminations, etc., and hence will accuracy and improvement. Now let us look at maximization of available resources. Now, currently, what is happening actually, I was telling, available resources are independent of each other. Okay, it leads to, I know in your country also, flash flood guidance is issued by everyone one, and quantitative precision forecast is issued by another one. Okay, district level heavy rainfall warning is issued one, and then subdivision level warning is issued by one. Location specific forecast is issued by another one. So by that way, there are 5 to 6 rosters running, and if you are running 5 to 6 rosters, you need 5-6 persons, and you may not have the 5-6, for example, class or meteorologist. So by that way, what is happening usually? You neglect, isn't it? So this is the case what I wanted to say, that you need therefore planned training activities, and accordingly the actions, the resource also to be utilized. Say there is example I told you for med subdivision. So how you are facing the problems, because you say that there is no people, because people are diverted, people are scattered like this. You are not utilizing the people available, you are not utilizing the manpower available, you are not utilizing the computing system available. Everyone wants for computing resources, but the same computing resource can be utilized for everyone. So this is the ideal case, one example I am giving you, how all the common resource can be utilized and manpower can be minimized, and we can have the better result. And the same people who are available, let them discuss, let them prepare their knowledge, experience, expertise, and fine tune the forecast. That can help. Okay. Now, next point I want to say, the development of synergized SOP. Say, for example, now there is an SOP for flash flood guidance. There is an SOP for cyclone. There is an SOP for QPF. There is an SOP for Southeast Asia Severe program. All these SOPs are different from each other. They are not compatible. It has to be a synergized SOP. For example, if I say cyclone warning is being issued, at that time, which flash flood guidance will be utilized? Which severe weather forecast guidance will be utilized for this purpose? If it is going separately and there is no synergy among the different types of bulletins and products being utilized, then it is creating a problem for the forecaster also, and for general public. You can just think of, if you yourself cannot understand what you're doing, how the general public or a disaster manager will understand? It's very difficult for them. One product has a validity period of 12 hours, another product has a validity period of 24 hours. How the disaster manager will interpret it? At what time the validity period starts, at what time the validity period ends? All these points are the limitations at present which can be addressed. In any country, it is happening like that. So SOP for early warning services needs to be synergized. This is one case I told you within minutes. Now, you issued an SOP. For example, we have got a flood warning center here, Central Water Commission. We issued our SOP. They have their own SOP. Whether they are synergized, at what time they are issuing. You issued the warning bulletin for a morning. At what time they are issuing the bulletin? Whether they have got the staff and mechanism to issue bulletin at the same time. I was telling an example of, say, cyclone warning is being issued every 3 hours. Whether at that time flood guidance is being updated at least 4 times a day or 3 times a day. So these are the issues, how the not only within the NMHS, but also NMHS and other agencies, service providers, also there should be synergized SOP. And similarly, other things. Now, next is the strengthening of national institutional coordination and arrangement. See, coordination and arrangement is very important. For example, how many of us go for a VC? There are a lot of ICT. The RSMC and the member countries can have a VC whenever there is a severe weather conditions. Even there can be WhatsApp communications. There should be WhatsApp group for each and everyone, so that there is a free flow of information. You take a decision as a regional partner, as a national partner, as a global partner. So the proposed one, that there should be some kind of coordination among the forecasters in the country, forecasters in the region under RSMC, then forecasters and climatologists. Sometimes what happens, I gave the example of Imran Khan or Sachin Tendulkar, where from you get the extreme information? It will come from climatologists. They are enjoying because they do not have extra duty. So they will be there. They are least bothered whether there is heavy rain or not. But we ensure that the climatologists also will be at work, and they will provide real-time extreme information every day. So today I got information, what is the lowest temperature in the country and where it occurred. where temperature has gone below 10 degrees Celsius. So this type of information will help me to provide the cold wave conditions, cold wave warnings. So this is the role of climate. Climatologists also should be taken into consideration on the board. Then forecasters and disaster managers or policymakers. There should be a group. For example, we have a group here, Central Weather Commission, IMD, and the National Disaster Response Force. Every day during flood season, they meet and finalize what is the forecast of rainfall, what is the flood forecast, accordingly, what should the deployment of National Disaster Response Force, in which area they should send the battalion. So this type of mechanism has to be in place. Then comes the forecasters and stakeholders. We have got many stakeholders. For example, for coastal states, we have got the ports, we have got the shipping, we have got the fishermen, we have got fishery officials. So there should be some kind of coordination. Then disaster managers, policymakers, forecasters, and media. Media is also very good. They can provide a lot of information, real-time information. They can provide you where it's what is happening. For example, you have got the crowdsourcing mechanism. In India, also you have got crowdsourcing mechanism. You can get information. Social media. Someone in the forecasting group should be in touch with social media. What is the response? What is the observations? They can provide a lot of information that should be utilized in your decision making. Then this is the sharing of data and products that I have told you. There are certain data which are not shared. It should be shared. More the data, more the merrier. I will tell you. More the merrier, we say. If you got more data, because it is such a science, it is a data-driven science. Meteorology is a data-driven science. So you got more data, you can have very good applications. So I will tell you one example. Say, for example, about DSS. When we developed the DSS initially, our flash flood guidance was not available in DSS. So a forecaster has to look at DSS for heavy rainfall warning. He has to look at another PC or another platform to look at the flash flood guidance. Again, flash flood guidance, whatever is available, that is in JPEG image. You cannot zoom in and zoom out. Now, FFG is available in DSS. So that the product which is available for flash flood, the product is available for heavy rainfall, all are in one place. A disaster manager, a forecaster can look at both at the same time and accordingly can take a decision. That is, impact-based forecast can be generated in a better way. So inclusion of all these in single platform led to improvement. I'll tell you, it has led to improvement of 5 to 10%. By development of DSS in IMD has helped the significant improvement. At least 10% forecast accuracy is improved because of that. But still, we have got the way forward. For example, QPF is not integrated so far in DSS. So many things are there. So what I want to say that the development of a system, taking into consideration the requirement of end users by this way with the DSS can help you. Now there comes whether it is possible, the integration of various services into one package. Is it possible? Yes, it is possible. And how? Through development of DSS. We have to develop the DSS. There should be free flow of data to DSS. There should be compatibility of data. There should be robust data communication system and IT infrastructure. There should be a policy decision. Your DG should decide, yes, we have to go for that. If policy decision is not there, you cannot do that. So it is steered by the policymakers. Then there should be cooperation among the meteorologists. It is very important. If meteorologists do not talk to each other, do not share each other, do not exchange with each other, it will not succeed. They are the backbone. Meteorologists should cooperate with each other. There is development of framework, SOP, guideline for this purpose. The interoperable environments needs for this. Then development of common training program for users, stakeholders, and system administrators. Also, you need training. Even for policymakers, also you may need a training to understand them, to let them understand the objective. Now comes minimization of number of bulletins and development of consolidated bulletin as per the user requirements. There is no need to give 4 or 5 bulletins as I discussed, for example, heavy rainfall. It should be only one bulletin. It should include every information and it should summarize. It should given what is the impact expected and action suggested for disaster managers, general public. So that we are doing for cyclone. If you visit any cyclone, national bulletin of cyclone, will find out how it is being provided for each and every aspects. So what you need actually, you will find that these are redundant bulletins. Many bulletins are redundant. Okay, generated by different sources. Becomes difficult for implementation by stakeholders. It leads to different time update and validity period. It is more so when there is a rapid development. For example, there is rapid development of thunderstorms, and your bulletins are going in different modes, different timings. It doesn't cater to the requirement. So all warning information in a single package for early and accurate extraction is essential. The severe weather event can steer the unification of bulletins. I am sure this program, severe weather forecast program, can steer the unification of bulletins. Example, I'm telling you out, for a landfalling cyclone, national bulletin on heavy rainfall warning should contain district-wise heavy rainfall warning, quantitative precipitation forecast, flood warning, flash flood guidance, storm surge warning in the absence of a unified package for flood depth and inundation mapping. Finally, is flood depth and inundation mapping. So if you are not having the decision support system, what you do at least you put all information in one place, one package, instead of giving different bulletins. Then further, in a multi-hazard scenario, it should contain wind warning and damage expected, wave warning, past rainfall, runoff, so that hydrological and hydrological modeling is there. So the entire expertise, because sometimes you know, because of the heavy rain also, tree can fall. Because the heavy rain leads to soil erosion, and hence tree can fall. At the same time, if you got a wind, say 45 kmph, both can combine. So if you are giving a forecast, heavy rainfall, but wind you are not mentioning, then real impact you are not considering. So therefore, you have to consider various parameters combination. You have to apprehend. Accordingly, it should be provided. So what you see then in interoperable environment for multi-hazard early warning system is an example of heavy rainfall can lead to riverine flooding, can flash flooding, urban flooding, coastal flooding, landslide, landslip, land sink, etc. So you've got different scenario now. You've got a model 1, for example. I've given name model 1. That means your forecast is going for riverine flooding one place. Then model 2, you have got, for example, flash flood. Number model 3 is urban flood. Model 4 is coastal flood. Model 5 is landslide. All 5 are working independent of each other now. Okay, just imagine. Now just imagine in a multi-interoperable environment, all these 5 modules will work together. And finally, it will provide the forecast. And all these, whatever I've discussed so far, this is the objective. This is the objective. We have to do this. It can be done. I'll take you one example. What can you done actually? So this is, for example, the multi-hazard impact-based forecasting, risk-based warning for heavy rainfall. If you want to go for that, you cannot consider only the heavy rainfall from the point rain gauges. You have to consider from different sources. Okay. So what are different sources? You have got the sources of satellite, radar, where you are getting also rainfall estimation. You are getting estimation from our point rainfall. And point rainfall may not be sufficient. So hilly areas or deserts, etc. You can go for analysis. So you have the analysis, you have point distribution. Then again, the flooding does not occur because of immediate rainfall in past 3 hours. Sometimes this flash flood can occur in 3 hours. But it also depends upon the soil moisture, soil saturation. Then we have to consider what is the past rainfall, cumulative impact. The past 24 hours rainfall, 48 hours rainfall, that is day 1 rainfall, day 1 plus day 2, day 1 plus day 2 plus day 3. We have made a system in our support system to look at the rainfall of to past 5 days, cumulatively and individually. And also there is a system for analysis and point distributions. And while do for this, you are going for actual rainfall, normal rainfall, and departure rainfall. Then you have got the all current observations. You have got surface observations, upper observations, satellite QPV, radar QP, etc. Then you have got the climatology of extremes that I was talking about. Example of Imran Khan. Or climatology of extreme is very important. You should have the climatology of extremes, suffer and fall for a particular district or particular place. Then you have got the models. You have got the NLP models. For example, you may have number of models. Say, for example, we have got 7 models being run in the morning and evening. 7 models to provide the 7 different forecasts. So then you have to go for multi-model ensemble. You have a consensus is to be developed. All these models are available for severe the forecast program. All these models are available to your country. So how to develop MME? We can help you to develop MME. We have developed MME. And this MME will give you the objective consensus forecast. Then you are going for synaptic analysis based on all observations. Then you are finalizing the operational forecast. That operational forecast that you prepared, based on that, considering the past rainfall, etc., you are going for hazard information. Past and current gives you the hazard information. And of course, forecast hazard also you have to give. Therefore, you look at the forecast rainfall for day 1, day 2, day 3, day 4, day 5. At present, to give forecast for 5 days and various combinations. So all these will provide you now in very short nutshell. I explain you. Details will be discussed by Dr. Janamani when he goes for heavy rainfall module. All these will give you the assessment of the past rainfall, current rainfall, forecast rainfall, hazard assessment. Then you are going for the sector-specific products generations. You have got a production module. In the production module, you have to utilize the standard SOP. Then customized bulletins, etc., has to be generated. At the same time, there is impact information, vulnerability information, socioeconomic information, geophysical parameters. All these are available in DSS, and they can be utilized. And finally, impact-based forecast and risk-based warning can be provided. At the same time, real time, you are getting the feedback from the stakeholders, the public, that should take into consideration. Forecast should be verified on daily basis. Don't wait for forecast verification at the end of the season or end of the month. You have issued forecast yesterday. What has happened today? That you should know. If you know that, you know what is the bias of the model, you know what is the bias of your forecast, then course correction can be done for today, and by that way, you can improve the forecast. I think Dr. Manik is here. We did this exercise to ensure that yes, there is forecast improvement of 5 to 10% if you are verifying the forecast. If you are not verifying the forecast, your forecast will go wrong. If you are not making the bias correction, your forecast will go wrong. You can make bias correction based on the past performance of the model, past 24 hours. Then, based on the historical performance for last season, then consider the initial condition of the model today. Which model, say for example, there is a cyclone circulation, because of that heavy rainfall is occurring. Which model is picked up that cyclone circulation well? If the model is picking up, then its forecast can be correct. If model is not picking up the historical initial conditions, then your forecast can be correct. You can translate the rainfall forecast given by the model to a common place where you have predicted. By that way, you can find out the probability of occurrence of rainfall. You can find out the confidence of your forecast. So this is the in nutshell, this is the SOP. You will be discussed afterwards also. So this is the rainfall data where from you will get. I have discussed all these things. Where from you will get this data? You can get the data. Data are available from satellite, data are available from radar, data are available from observational states. So all these data should be utilized. You should know where from rainfall data. What I told, all these data should be acquired and visualized in a decision support system. In the absence of decision support system, you have to do it laboriously, qualitatively, subjectively, on your own way. But again, apart from rainfall data, you have to consider soil moisture. There are soil moisture models, there are soil moisture observations. You have to consider land use, land cover. You have to consider physiography. Sources are there, NRSC, IRS that are there. For example, you have got socioeconomic data. We have got web DCRA, dynamic composite risk atlas, where also you get soil moisture and many other parameters. The analog data, you have got analog data. Analog data means what? There are many synaptic analogs. For example, for heavy rainfall, there are many synaptic analogs. If this is the case of low pressure area, where the heavy rainfall occurs, many countries have developed synaptic analog. We also have synaptic analog. So many analogs, nowadays many developed analogs have come up. Very simple analog I'm talking about, synaptic analog. Then you can go for geospatial data. Yes, in country we have taken Survey of India, Geological Survey of India, urban meteorological data, etc. Climate hazard and extreme rainfall, that analysis has been carried out based on the past data. Hazard and vulnerability atlas has been prepared of IMD. That also you can look at sometimes. Then other data, flash flood data, etc. are there. So all these data has to be accumulated and put up in one place to take a decision. So this is just an example of LULC data. The top one is land use, land cover data, and the second one is the MODIS data. What is can be utilized? There are many informations available free of cost, which can be utilized to assess your impact-based forecast. NDVI data is there. So this is the prototype of DSS what we have developed in IMD. What you need, I am giving this information because you can go for the development of that. So you need a front end, you need a back end. Front end means it will be given to the public, disaster managers. Back end means you are working here, what to develop and what information you take for decision making within your NMHS. So this is the software and this is the platform which we have developed, which we can help you if you want to develop like that. I think all of you might have developed something also. Now I will take an example now. This is a case of 22 August 2021. Okay, 2021, 2022. Okay. There was you can see the red circle. Red circle, you find that there are certain dots. These dots are the heavy rainfall. So on the day today, I have to give a forecast. On 22nd August, I have to give a forecast. So what shall I do? First, I will see what is the rainfall in the past. So past rainfall for day 1 is on the leftmost corner, north and left, top and left, day 1 forecast. Past 24-hour rainfall. Second one is past 48-hour rainfall. Third one is the past 72 hours rainfall. Like that, 7 days rainfall I am taking into consideration. I find that the area of East Rajasthan and West Madhya Pradesh is now becoming very prone for flood because last 7 days it is raining there. Last 7 days. This information comes from the past data. Without any forecast, I can issue the flood warning today. I'll tell you. Because I'm looking at rainfall is occurring for past 7 days in that area. Whatever give a forecast, flood will be there. Okay. So this is the strength of continuous monitoring of the rainfall. Now let us look at. I have just put up that circle. I have just copied here and put up. This is the climatological guidance of heavy rainfall for floods. The left one is the heavy rainfall. the top left. Right one is the very heavy rainfall and extremely heavy rainfall. You see, in the past also there has been the heavy rainfall and very heavy rainfall activity in that area. Okay, that means that area is prone for heavy to very heavy rainfall, extremely rainfall activity. So this time, so people should tell the people why we are expecting extremely heavy rainfall activity, and this area is prone. Past data suggests that area is prone, and therefore whether flood has occurred or not. Yeah, let us see the third one. Third is normalized vulnerability index for flood. So the vulnerability index shows the yellow color. Yes, there is vulnerability. The area is vulnerable for flood. And fourth one is the total number of flood events that has occurred in the month of August based on data of 1969 to 2019. So number is showing 10 to 30 numbers of floods have occurred in the past data of 1969 to 2019. So roughly about 60 years, 50 years. In the 50 years, there has been 10 to 30 number of cases of floods. I am telling to the public now. Okay, I am giving you the heavy rainfall warning today, and this area has experienced flood 30 times in 50 years. Yes, then I. So by that way, we are telling that yes, this is a flood prone area. Okay. Now next, I am looking at now flash flood guidance system. Rahul is here, so it helped me. I took the data from flash flood guidance system. Flash flood guidance system has the facility to have the soil moisture, to have the data on the global hydro estimator. The left one, top left, is the global hydro estimator based on microwave. We know how much rain has occurred. You see, East Rajasthan and West Madhya Pradesh. The area is telling that microwave says that there has been rainfall. And then global hydro estimator GHC data is also there. Then gauge on right hand side. On the bottom panel, we have got the gauge mean aerial precipitation. It is also showing that this much of rainfall has occurred. Then map most mean area precipitation is also shown on the right in the bottom. So all these things are indicating you in the current scenario how much is rainfall. Even if you do not have data, actual data, you are getting information from the satellites. Now this is the interactive dashboard. Now I have to give a forecast. So I selected for day one all the models. Now this is the superimposition of all the models. Okay, so you can find out how the East Rajasthan and West MP area, all models are showing that there will be heavy rain. Okay, I'll just put up in one day. Now let us look at like that individual model. IMD GFS, NCOM, NCEP, JMA, GFS, ECMWF, MME. Now all these models are showing that there will be heavy rainfall, and taking into consideration the drawn polygon is shown here, right hand side, the drawn polygon, the area where we are expecting the heavy rainfall. Now this is for say example 24-hour forecast, very heavy rainfall. What is the probability of very heavy rainfall? Yes, there are different models here. You have got 7 models, and then you have got 6 models. Then you have got multi-model ensemble. Based on that, polygon is drawn the area where you can expect very heavy rainfall. Now let us look at the extreme heavy rainfall. This is the guidance for extreme heavy rainfall for different models, and you are getting the drawn polygon. Now I've come up to the drawn polygon where you can expect the extremely heavy rainfall. Okay. Now finally, based on all these, we are providing a forecast of the probability of occurrence. This is the area of probability of occurrence. It is DSS. All these things are being done by DSS. You got the probability of occurrence of heavy rainfall, extreme heavy rainfall, etc. in East Rajasthan and West MP. I'm targeting that area. I'm not discussing other areas. Then we also take into consideration what is the forecast verification. I know in 24 hours my forecast accuracy is 80%. It is improved. In 2022 is 80%. I'm providing the forecast this year. So I'm taking the forecast accuracy 22 80%. So while telling all these things, I should remember that there could be error of 20%. There could be false alarm also 20 to 30%. Now finally, this is the district-wise impact-based forecast issued by our Met Center Jaipur. Okay, so this is the forecast we issued based on 12 UTC, based on 0 UTC 22nd. Then this is the flash flood guidance issued by our flash flood guidance center. And then this is there are two information. One is the flash flood threat, other is the flash flood risk. Next 6 hours, next 24 hours. Then you have got this is the quantitative precipitation forecast by FMO. So what I want to say, all these things are being provided by different sources, but I am telling you this case we did to make it common, and it has been common like this. So this QPF is also issued by different reforecastments. This is for day 1 forecast and day 2 forecast. And finally, we gave the impact-based forecast. We draw the polygon, and left-hand side is the area of polygon where you are issuing the severe weather warning and impact based warning. And right hand side is zoomed area where it is showing the hospitals, airports, power stations, power plants, oil refineries, sports stadiums, special economic zone, roads, railways, district boundary, affected areas, and so subdivisions, etc. So all the information, I've shown certain informations. There are more informations also. Yeah. I'm coming just. I'm coming. ठीक है. Okay. ठीक है. Fine. So like these are the impact expected, we told to the public. Okay, and this is the impact actually what happened, past rainfall estimation and its impact. You can see the flood occurred like this and forecast was issued like that. What happened rainfall, what is the impact, this is the forecast verification. So with this I just gave an example how the multi-hazard early warning system interoperable environment can be ensured for this region. It can be done and we can start it, and we have demonstrated here. We are working towards that. It can be done. So thank you very much. We'll meet again afterwards. I have to go for a meeting.
Yeah. Thank you very much, sir, for very comprehensive talk. And sir has to rush for some other meeting. So, okay, thank you, sir. So now